This new section is entitled Factoring by Grouping. Suppose you have ax plus bx plus ay plus by. Whenever you try to do factoring, you should try to find out what's common in all the terms, if anything. These are the terms. This term plus this one plus this one plus this one. Okay, we want to find out what factors, if any, are in all four of them. Well, the factors of the first term are a and x. Factors are things that are being multiplied. B times y. I underlined the factors in each and every term. A is a factor of the first term, but you know what? It's not a factor of the second term. So A couldn't possibly be a factor of all four terms. It's not a factor of the second one. The bracket is not a factor of the last one either. So now we're left with x. Maybe x is common in all of them. Well, there's x in the second one, but you know what? X is not in the third one. Nothing is common in all four. You may say, well, what about b? What about b? You didn't mention b yet. You didn't mention y yet. Well, if they weren't in the first one, the first term, they can't possibly be in all four terms. Okay, so now you say, all right, now I'm confused. There is nothing that I can factor out. Does that mean I'm done? Well, not necessarily. You should always factor out what's coming first, and then use some other techniques. When you see four terms, you should think about factoring by grouping. You group the first two terms, you group the last two terms. And then you factor each grouping separately. This being the first grouping, and this being the second group. In the first group, you can pull out an x. And what's left over is what I didn't underline, namely a plus b. There it is. Plus. Here, I can pull out a y. That's common. And what's left over is a plus b. Okay, now I factor the whole thing at once. Between this term and this term, they both have a plus b. What's left over is what I didn't underline, x plus y. And what was common was even the brackets. That's why I put a plus b in brackets. What I didn't underline, like I said, was x plus y. And we just did our first factoring by grouping problem. Okay, let's try another one. You should always try to factor out something if it's in common. If you have c squared d plus c squared e plus cjd plus cje. Well, they all have, so what I'm asking is to see what we're factoring out is, you look at each term, c squared d and c squared e and cjd and cje. The last two terms, those are c's and not e's. Well, they all four have c's in common and nothing else. Now, the only thing, according to the first term, the only other thing that can be common is a d. But for example, the second term didn't have a d. So c is common and the power is a c. 2, the understood 1 and the understood 1. Between these four numbers, what's the smallest number? 1. So the answer is c to the 1 or c. That is what GCF is all about. You can pull out a c. Now keep in mind that this is c times c times d. CCE. CJD plus CJE. And if I factor out my c, if I factor out a c from each term, I now write down what's left over. Namely CD plus CE plus JD plus JE. CD plus CE plus JD plus JE. So I factored out what was coming. But that doesn't mean I'm always done. It might mean I'm done. But in this case, in every case, you should think, well, can I do more? Whenever you see 4 terms, you should think about factoring by grouping. Inside these brackets, 4 terms. In fact, maybe I'll put big brackets around. Make believe those little brackets aren't there yet. Make believe these brackets aren't here yet. Save me a little time. So, I'm going to group. I'm going to group the first one. Now that little bracket is there. And now I'm going to group the second one. And this bracket is now there. So I have C times, and I'm going to try to factor the first bracket. Well, they both have a C in them. I pull out the C, and what's left over is the stuff that doesn't have the arrow pointing to them. That is everything but the C. And plus, in the second bracket, I can pull out the J. And what goes in the bracket is what I didn't cross off, namely D plus E. Close the bracket. Now, if factoring by grouping is going to work, this and that should be the same, and they are. So I factor it out. And what's left over is C plus J. And C plus J. Big bracket. Now you can leave the answer like that, or you can say, you know what, I don't even need the big brackets. I don't even need the big brackets. This is like one letter, and this is like another letter. Say big A and big B. Little c, which is in front, times A times B. Let's use little brackets. That's the associative law. Associative law says that C times A times B, well, you can do A times B first and multiply that by C. That is, you don't need the big bracket. The associative law says you don't have to do the last 2 first. You can do the first times the second times the third. But you want to leave the brackets, leave them. In the end, there's the answer. Either or for the last 2 lines. You could leave the answer like this one, or you can leave the answer like this. They're both exactly the same. Alright, now let's look at that first problem again. I'm going to write it down, but it has, just so you see that it's going to be like the problem I'm going to write beneath it. This here was the first problem. And it actually turns out that it's going to equal this one. It's going to equal this one. They both have AX, they both have plus BY, they both have plus BX, they both have plus AY. They are equal. So when we factor it, we should get the same answer. So what you try to do is, let me write it down so I don't write on your original problem, which is this so much. You group the first 2, you group the last 2. But that's kind of as far as you can get, because there's nothing common in here to factor. There's nothing common in here to factor. And you want to say, well, I'm done. But then you realize, wait a minute, it actually, this beginning problem is actually the same as the top line, which we factored earlier. And then you say, oh my, what do I do? And the answer is, you have to reorder. You have to reorder, so there will be something in common in the first bracket and the second bracket. For example, if you put AX plus AY in one bracket, clearly, like I said, AX plus AY, I wrote BY. If you write AX plus AY in the first bracket, well then the A's will be common. And then in the second bracket, you write by plus bx. And it actually turns out that the b's will be in common. So sometimes you may have to reorder to get things common. First bracket, I factor out the a, and I'm left with x plus y. In the second parenthesis, I pull out the b, and I'm left with y plus x. And you say, well, these don't look like one another. Oh yeah, addition commutes. Y plus x, that's the same as x plus y. In fact, they are the same. So you factor it out, and you're left with a plus b in the next bracket. And when we did the very first problem, I'm pretty sure we got a plus b times x plus y. But these are the same answers. Multiplication commutes. That is, this last line is the same as a plus b times x plus y. This times that is always the same as that times this. 3 times 4 is 4 times 3. R times S is S times R. Multiplication commutes. So we are getting the same answer, but for this bottom line that remains, the beginning problem, ax plus by plus bx plus ay, grouping the first two and grouping the second two didn't work. We just had to group differently. We had to rearrange the terms. And notice we rearranged it differently than the very, very first problem we did, and we still got the same answer. Now, little problem. You have ax minus by plus minus ay plus by. Minus ay plus by. Suppose we have that. Well, this is equal to itself. This is equal to itself. Now, if we group the first two and group the second two, are these equal? Well, let's be real careful what this middle line equals. Well, it equals ax minus bx. Well, now you have to, which is exactly what we have up here. Now you have to take away ay. Yep, that's exactly what it says. So now it says you have to take, now positive by is just by. Just like positive 7 is just 7. If you take away by, well then, you take away by, and you say, oh my, we were supposed to add by. In fact, if it were a minus in the middle, if it was a minus here, well, here we have minus by. But here we're not taking away by. We're taking away negative by. Taking away negative by, well, you learned you can change both of them. It's the same as adding by, which is not what this says. Okay, let me put the plus back. Now, here's the rule. Let me get rid of this third line. That was just our check to realize the second line right now does not equal the first line. So we have a little problem there. They need to be equal. And here's the rule. If you have a minus in the middle, after you group the first and second, you must change that sign. The middle sign in the second bracket. Regardless of what it is, change it to the other sign. If it was plus, we put minus. Okay. If you have a minus in the middle after you group the first two and the last two, you must now go and change that sign in the middle. If it was a plus, you change it to minus. It's called the rule. Okay, now we factor by grouping. In the first bracket, we can pull out an x. And what's left over is A, take away B. Minus. In the second bracket, we pull out a Y. And what's left over is A minus B. A minus B. And since those are the same, we write it down, and then we write down the X minus Y, and there's the answer. Now, there's a built-in check here. There is a built-in check, or a built-in way of finding out that you made a mistake. There's a built-in check, which is really good. You can make a mistake, and the problem's going to scream at you like, hey, you made that mistake. If you just write down the problem, and you group the first two and group the second two, and forget, since that's a minus, you should change that. Don't worry too much. You factor out the X, and you're left with A minus B. A minus B minus, and you factor out the Y, which I forgot to do. And now here it is. You're left with A plus B. And then you say, oh my, these are not the same. These are not the same. What did I do wrong? Oh, yeah. If this is a minus, I had to change that sign. In this case, to a minus. That is, this plus should be a minus. Oh, great. Now these are the same. So it's A minus B times X minus Y. So you're going to get screamed at for not doing that. It's going to be right there like something's not working. Something's not working. This is A minus B, and we put A plus B there. Oh, yeah. This guy told me there's a minus in the middle. I have to change that plus sign to a minus. If there was a minus in the middle being over here, then I will change it to a plus. Okay, so how about we work backwards? Now, what we want to build up to is doing these problems where we factor quadratics. I don't like that one. Let's make it 7. If you were given the results of this to factor, you'd have 6x squared minus 14x's plus 9x's. That sounds like negative 5x's minus 21. That's your beginning problem. If you were given 6x squared minus 5x minus 21, and you were asked to factor this, well, you can't play the x followed by a number game, because that only works if x is 1. So one way of solving this is to factor by grouping. You multiply the number by x squared by the constant. 6 times negative 21 is negative 126. Now you want to find two other numbers that multiply out to negative 126, but add up to negative 5. Well, 1 and negative 126, they multiply out to 126, but they only add up to negative 125. 2 and negative 63, 3 and negative 42. These differ or add up to negative 39. So we're getting closer to negative 5. 4 is not going there. 6 does. 6 goes in there negative 21 times. The sum is negative 15. We're definitely moving in the right direction. Let's continue. Due to lack of space, I'll continue here. These added up to negative 61. So 7. Does 7 go into 126? Yes, it does. 7 goes in negative 7 into 126. It goes one time with 5 left over, and 7 into 56 is 18, negative 18. But unfortunately, they add up to negative 11. Does 8 go in there? I would think not if 4 didn't. Since 4 didn't, 8 will not. Does 9 go in there? Yes, it does. 9 goes in there negative 14 times, and there's your negative 5. Okay, it took you a while, but we got it. 9 and negative 14, or negative 14 and 9. Okay, now, you might have been saying, how can this be a factoring by grouping problem? There's only 3 terms. Very good. Very good. You've been listening to me. Well, we're going to make it 4 terms. We're going to rewrite the top line. We're going to write down the 6x squared. We're even going to write down the minus 21. But this middle term, negative 5x's, I'm going to write down plus 9x minus 14x's. Or am I going to do that? If I do that, I run into this silly problem. The fact that I don't know how to write 21. Okay. And the other silly problem is after I group the first 2 and the last 2, I get a minus in the middle. Why did I get a minus in the middle? Because that number was negative. If that number were positive, then I would have a positive in the middle. That is, you should, if you can, you should let the second number always be positive. And the first number, if it has to be negative, let it be negative. That way, you'll always have a positive in that middle. The only way this will not work is the 2 numbers here and here were both negative. Because if they're both positive, it doesn't matter which you put first. So I'm going to put negative 14x first and plus 9 second. And then things are going to work out smoothly from here. I will not have a negative in the middle. Take 6x squared minus 14x's plus 9x. I group the first 2, I group the second 2. And now we proceed like we have before. 4 terms, we factor each one. Between 6 and 14, the greatest common factor is 2. And between x squared and x, pull out the one with the smaller power, namely x to the 1. 2 times 3 gives me 6. Excuse me. X times x gives me x squared. Minus 2 times 7 gives me 14. I already have the x. Plus. Between 9 and 21, or between 9x and 21, I could pull out a 3. 3 times 3x gives me 9x, and 3 times negative 7 gives me negative 21. And then 3x minus 7 is common. I ran out of space, so I'm going across. And I write down what's left over, 2x plus 3. Unless I made a silly error, it's exactly what I started off with. Doesn't matter that I wrote 3x minus 7 first and 2x plus 3 second, because we are multiplying those 2. Multiplication commutes. Okay, let's try one more. So you should use this when the coefficient of x squared is other than 1. And you can make them up easily. Just, now, when I say that, let's just look at this. Suppose you have x squared or 2x squared plus 10x plus 12. Now, of course, that's not a 1. I would not use factoring by grouping here, because like always, you should first ask yourself, can you factor out anything? And the GCF of 2, 10, and 12 is 2. So you get x squared plus 5x plus 6. It's 2 times that. Now you want to factor what's in these brackets. But now there's an understood 1. So this is not, the top line is not a factoring by grouping problem, because you can factor out the 2. What made you think it's a factoring by grouping problem is that you had 2x squared. Well, factor out the 2. Okay, well, what if you have 5x minus 2 times, I don't know, 2x minus 5? You get 10x squared minus 25x minus 4 more x's, that's minus 29x's plus 10. So I'm going to start off with this problem and we're going to try to factor it. 10x squared minus 29x's plus 10. The first thing you should ask yourself is, can I factor out anything? And 29 is prime. That is, other than 1, the only number that goes into 29 is 29. And sorry, but 29 doesn't go into the tens. So, the factoring by grouping problem. Multiply the number by x squared by the constant. 10 times the positive 10 is 100. I want two numbers that multiply out to 100, but add up to negative 29. And if the two numbers multiply out to 100, that is positive 100, either they're both positive or they're both negative. But when you add the two numbers, you're supposed to get negative 29. You can't add two positive numbers and never get a negative. But when you add two negative numbers, you get a negative. The two numbers are negative. And I just saw the answer. 25 and negative 4. They multiply out to negative 100, the positive 100, but they add up to negative 29. The unfortunate thing is, though, they're both negative. I can't get this second number to be positive. If I had 25 and negative 4, well then I would just switch it. I put the negative 4 and the 25 there. But it's not 25, it's negative 25. Okay, so now what I have to do is rewrite the top line. I'm going to rewrite it. Make it into 4 terms. Can't be a factoring by grouping problem if it's only 3 terms. So we're going to break up the negative 29x's to negative 25x's minus 4x's. That's the minus 29x's. So we still have the 10x squared and we still have the plus 10. The 10x squared and the plus 10. And now we factor by grouping. That is, we group them. This equals the top line. We group the first 2. We group the second 2. And we say, oh boy, there's a minus in the middle. So I must go to the second bracket and change the sign in the middle. It was plus, it is now minus. And now everything's fine. Between 10x squared and 25x, I can factor out 5x. 5 times 2 gives me 10. X times x gives me x squared. Minus. 5 times 5 gives me the 25. I already have the x. I factor the first bracket. Minus. The second bracket, between 4x and 10, 2 is common. 2 times 2 gives me the 4 times x gives me 4x. Minus. 2 times 5 gives me the 10. And then I say, yeah, this looks like it's working, because these are the same. Factor it out, and then write down what you didn't factor out. Namely the 5x minus 2. 5x minus 2. And that's exactly what I started with. You're leaving it check. If you want to erase this completely and never talk about it again, fine. Here's the problem we're going to do. Forget about, write it down on top, and then work it out. There's the answer. If you wanted to check, you should just FOIL it out and make sure you get the top line. Okay, that's how you do factoring by grouping. The first few problems, they were set up to be done by grouping. You were given the 4 terms. But when you have a quadratic, you're going to have to do stuff to it to get it to be 4 terms and then factor it. Okay, good luck with this.